In this video, we will investigate several basic properties of sine and cosine. So the first of which is that the values of sine and the values of cosine are always greater than or equal to -1, less than or equal to 1. And if you go back to the previous video and look at how we've defined the trig functions in terms of the unit circle, you can see why it makes sense that their values always have to be between -1 and 1. Additionally, sine of t plus 2 pi is sine of t, cosine of t plus 2 pi is cosine t. As we'll discuss in the next video, this is just a way of saying that sine and cosine are periodic functions with period 2 pi. Furthermore, sine is an odd function. So sine of minus t is minus sine of t, and cosine is an even function. Cosine minus t is cosine t. So note graphically what this tells us is that the graph of sine has an origin symmetry, and the graph of cosine is symmetric about the y-axis. The next property just gives us a relationship between how you can go from between the graphs of cosine and sine. And then the last basic property, cosine squared plus sine squared equals 1, is the familiar Pythagorean identity. Let's go ahead and use this last identity, the Pythagorean identity, to derive the fact that 1 plus tangent squared is equal to secant squared. So starting with the Pythagorean identity, cosine squared plus sine squared equals 1. Well, if this identity is true, what I can do is just modify it algebraically. And one way I can modify it algebraically is to divide everything by the same quantity. So let's divide each term by cosine squared. And when we divide each term by cosine squared, the first term becomes 1. The second is sine squared over cosine squared, which is tangent squared. And then on the right-hand side, the 1 over cosine squared is simply secant squared. So if you remember the Pythagorean identity, you can modify it to get two other related Pythagorean identities. So let's determine if the following functions are even, odd, or neither. So to determine if the function is even or odd, what we have to do is plug in minus x and see how that's related to the original function. So f of minus x is secant of minus x, and we need to recall that secant is 1 over cosine. So 1 over cosine of minus x. Cosine, as we saw in the basic properties, is an even function. So cosine of minus x is cosine of x. 1 over cosine is secant, and secant x is f of x. So this long equality is showing us that f of minus x is equal to f of x. And that applies that the function is even. For the second function, we can proceed in the same fashion. G of minus x is minus x cosine minus x. Cosine minus x is cosine x because cosine is even. And the x cosine x is just g of x. So g of minus x is equal to minus g of x, which tells us that x times cosine x is an odd function, i.e. its graph will be symmetric to the origin.